Okay, good morning. So let us continue the lesson. There are two theorems. One of them is called top triangle theorem and the other one is called transversal theorem. I don't know, this is more or less a translation that I did from your book, so I haven't heard about it because the transversal theorem, I was consider it to be the two parallel line with the transversal. More or less the content is related, but anyway, this is the names that this is used in Swedish system probably. Top triangle theorem and transversal theorem. What are these theorems? They are very easy, by the way, and very handy. You need to learn them very good. So if you have a triangle, let us talk about this one first. This is claiming this. If you have an arbitrary triangle, whatever that triangle is, if you pick a point on one of these sides, say for example, I take a point M wherever I want on this side, for example here, and from here I draw a parallel line to one of these sides, either this one or that one, but let me just do this one. So I draw this line parallel to this, so that it goes and intersects the other side at point N. So what I am doing, I am just drawing MN parallel to BC. Now the claim is this, which is of course very easy to understand. The claim is that when you do this, you generate a new triangle. This triangle is similar to the old one. It's very, very simple to understand. So this means that the triangle AMN is similar to the original triangle ABC. But of course, for any claim, you should be able to argue why this is true. But this is very, very simple, I think, in this case. Anyone can tell me why this top triangle? That's why this name. The top triangle is similar to the original triangle. So why is that the case? Yes, Rasmus?
Because the line MN and BC are parallel,
yes.
The angles between AC and AB to this.
Yes. So what you're saying is that you are using this idea that if I have two parallel lines and a transversal line, then this angle here corresponds to this angle here.
Yeah.
So that's a pair of corresponding angles.
Yeah.
And because of corresponding angle axioms, these two are equal. So that's correct. So you would say that MN is parallel to BC. Why? Because you just told me that this is the case. And then I would say that let me write this for AB is a transversal. The transversal. Or a transversal. Okay, so from these two, I can conclude that the angle AMN, or let me write it M1 and B1. So there is no need to say B1. So angle M1 is equal to angle B. Okay, but we need something more. Yes, it's not enough. So can you continue, Rasmus, yourself?
Yeah, then we can say that, or wasn't it to conclude that two triangles are similar? We need to know that was it enough to just have two angles?
Two angles. So what's the next angle?
The M and C angle.
You can talk about this one, but I would prefer to talk about A. That's also correct because A is in common. Okay, yeah. So I would say that A is also equal to A, the angle in common, yes? Okay, from these two, then I would say that, therefore, by angle-angle theorem, we conclude that the triangle AMN is indeed similar to the triangle ABC, and we are done. Yes? It's very, very simple. But what is in your book called Transversal Theorem here is that if I give you the length of this one A, the length of this part B, the length of this C, and the length of this D, so this is the top triangle theorem, This is the content of the top triangle theorem. But I can write another claim here, and that is interesting. The length A over length B is exactly equal to the length C over length D. So this is transversal theorem. So this means that if I have a triangle, if I take one point on one edge and then draw a line parallel to the one of these sides, then what I will get, first of all, I generate a triangle which is definitely similar to the original one, and this is the proof. But something also very interesting and very handy is that the ratio of these sides, so this line segment divided by the length of this line segment becomes a fraction. And if you do the same thing on the other hand, it becomes also a fraction. This claims that these two fractions are always equal. But why is that? Why do you think that these fractions A over B and C over D should be exactly the same? Yes?
Isn't it because the triangles are similar?
Okay, but if the triangles are similar, what can I write? Let us understand.
Then
So you are saying that the triangle AMN is similar to the triangle ABC. So what can you conclude?
you can conclude that the sides divided by the...
Okay, so tell me which sides. Of course, sides. B is not a side of any triangle. Yes, A is a side of a triangle, but B is just a part of a side. It's not the side itself. But you can write what? If you want, you can write AM. So let us consider the sides of the top triangle. AM, AN, and MN. If I choose to write these ones on top, you can just tell me what should I write. Then you have to uniquely tell me what to write below this one. If I write AM from AMN triangle, what should I write below that AM from the bigger triangle?
AB.
A. So I have to write AB, yes? And then if I decide to write AN, what should I write below it?
AC.
AC. And if I decide to write MN, I have to write BC. Okay? This is true. And if I want to write it down, okay, let us forget about this one. It doesn't help us for this purpose. It's correct, but we don't need it. Let us concentrate on these two. Instead of AM, I can write safely A, little a. So that's correct. But what can I write for AB? AB is from here to here. It's neither A nor B. It is A plus B. So instead of AB, I write A plus B equals to. On the right hand side, instead of AN, I can write C, but over what? AC. But AC is from here to there, so it is C plus D. So it is C plus D. So what I get is this combination, which is definitely true, but that is not exactly what is claimed to be true here. So I have to show you, convince you, that using this equality, which is true based on the first theorem, I can also conclude that. But I think that's also very easy. Why is that? Because now forget about geometry. we jump to the realm of algebra, yes? So I have a fraction equals to another fraction. This happens if and only if a times c plus d is equal to what? C times a plus b. Yes? But then this happens if and only if I multiply a inside, so it becomes ac plus ad equals to ca plus bc. But then suddenly you see this is exactly the same thing here. So I can move it to the left, make it negative, and then cancel it out, yes? And then what is left for me is AD equals to BC. And then the one last step is to divide everything by BD. So I divide everything by BD. This number is equal to that number. So if I divide the left-hand side by BD and I divide the right-hand side by BD, these two should also be equal. But then the nice thing is that, what happened here? I want to have, yes, that's correct. And then this D and that D are cancelled here. This B and that B are cancelled here. And then you can immediately see that you have A over B equals to C over D. So I mean that in principle, I will not be able to get this directly. What I get directly from the first theorem is this, but because algebraically it is equivalent to that, so I can say that that's also true. By the way, it's good to remember both of them, yes? So what I write, so similarity tells me that I can write A over the whole thing equals to C over the whole thing. In this case, I can also include the third side and write Mn over Bc. So if you decide to do like this, if you write Am over the whole AB equals to An over the whole AC, you can also continue if you want to and write Mn over Bc as well. Yes? But if you decide not to do that, if you decide to write piece over a piece, you know, a part over this part, so just say A over B, you can write C over D, but you're not allowed to write Mn over Bc. So you have to be careful which one you are using. Are you using the similarity argument? Then this is the way that you have to write. Then of course you have three fractions equal. But if you want to decide to write piece over this piece, then you are not allowed to write the third side. Okay, so be careful. You're not allowed to involve the third side as well. Yes?
So since the top triangle theorem is based on an axiom, or at least a part of it is an axiom, why is it called a theorem? Shouldn't it be an axiom as well?
No. Because now we were able to prove it. For the axiom, it means that we cannot argue, we cannot prove it. We have to accept that this is true. But this is a theorem because this tells you that if you accept that axiom is true, then we can reason, we can argue why this one is also true. So that's a theorem and needs proof. But this means that if for some reason we realize that that axiom is false, then this one will also collapse. Yes, because this argument is based on the truth of that axiom. Okay? But in that axiom we didn't present at all any proof, but here we are saying the proof, but the proof is based on that theory. On that axiom. Yes? Yeah?
How come we can't do Mn over Bc if we do it piece by piece?
No, because you see that it is on that picture. If you want to write Mn over Bc, then you have to write Am over Ab.
Oh yeah, right.
Yes, and you have to write An over Ac. If you write Am over Mb, there is no guarantee that Am over Mb is equal to Mn over Bc. because MB is not a side of any triangle. Yes. Ali, do you have any question?
I wanted to point out to prove that these triangles are similar. We use an axiom, right? Because
No, that's not an axiom. We didn't go
they
through the
transfer.
proof. No, we didn't prove angle-angle theorem. If you remember, I called it angle-angle theorem. But I told you that because the proof is not included in the book, so I just skipped that. Yes? We didn't prove anything yesterday. I just told you that the definition of similarity is to prove that all angles are equal and prove that the ratios of the corresponding sides are also equal. That's the definition. Then I told you that you really don't need to check all the details. So if you have only two angles from one with two angles from the other, they are similar. But I didn't prove that, even though it's a theorem and it needs proof. That's not an axiom. Yes? But at this level, you can consider it an axiom because the theorem is not proved in the book. Yes? If I continue these Olympiad lessons, definitely I will actually go through this very systematically. Any other questions? Okay, so I think the examples are actually very simple now. So let me, for example, what they have done, let me just solve these two problems and then we can choose some from the exercises. So, if I understand it correctly, so there is a picture here in the book. So, we have this, for example, and then you have C here, and then something like that. In the triangle ABC, DE is parallel to AB, and this is DE. So they have already mentioned in the problem itself that DE is parallel to AB, so it means that you can use these results here. You are supposed to determine the length of AD and DE. Okay, so this length is called X, this length is called Y, and the other numbers are 2.5, 2, 0, and then 4, 0, and then you have 5, 1. Okay, so in this problem, it's a very standard problem, simple one. You are supposed to find these unknown pieces. One piece is this one, another piece is that one. So you want to find the numbers here. So it's very simple, yes? Because you say that this DE is parallel to AB. So what I can do, if you want to find X, you can use this transversal theorem, yes? Because you can immediately write 2, 5 divided by X is equal to 2, 0 divided by 4, 0. Yes, is that understandable? As simple as that. But then 2, 5 divided by X, I can simplify always, so that's 1 over 2, 0. But then X times 1 means X is equal this one times that one, which is 5. Yes, 5, 0. But of course, I don't know, might be everything is in centimeters, let us assume that. Then X becomes 5 centimeters. That's correct. But if I want to find Y, this is not that helpful to use this transversal theorem because Y side is involved. So I have to use top angle theorem. So I have to use the fact that this is similar to the bigger one. Yes. In that case, I can bring these into the game. Yes. So I would say that, for example, I would say 2, but be careful this time. You are not allowed, if you want to get this involved, you cannot write 2 over 4. You have to write 2 over the whole side, which is 2 plus 4, equals to, then you can write Y over this one, 5, 1. Yes? Is that understandable? So be careful. So then it's simple. Then it becomes 2 over 6 is equal to Y over 5, 1. So this means that I can simplify that 1 over 3. Then 3 times y is equal to 5 comma 1. And then y is this number divided by 3, whatever it is. So it is 1.7, I think, yes. It's 1.7 centimeters. This means that I was able to find this length as well. Is that clear? It's a very, very simple calculation. Another example is also very simple in the book, you see. So you have this picture here. You have A, and then you have C, and then you have B here. Okay, in this triangle, AC is given to 9 centimeters, and BC is given to be 6,3 centimeters. And then the question is that from a point on AC, which is a distance 3 from A, you draw a parallel line to AB. So what does it mean? It means that I will find a point on AC, let us call it D, whose distance from A is 3. From this point, I draw a parallel line to this side. It will go and intersect this line at some point E. You want to calculate the distance of E to B. But is it enough for us or not? BC is also given, yes. That's enough. So the question is that AC is 9. You go 3 units up, find point D. You draw a parallel line to AB. It goes and intersects the other side at E. You want to calculate what is the distance from E to B. So what should I do? So I want to find the distance from E to B, so it is natural to call it X and ask what X is. So how can I solve the problem? Let me show you that this is parallel to this one. This is the symbol that we use. This line is parallel to that. Yes?
So first you can
May you speak louder, please?
you can find the ratio.
This one?
Yeah, so C.
DC. So AC is 9, this is 3, so what is left here? Clearly 6, yes?
And then you can also find we know the whole BC.
Yes, we know the whole BC is 6,3.
Yeah, so if the whole is 6,3, then only the CE part should be the same, like the CE divided by BC should be equal to 3 divided.
Okay, but I mean, what can I write for here? Don't make it complicated. So far, so good. But what can I write for CE? Of course, I cannot write a definite number for CE, but I can write something for CE. What that is? Yes?
6.3 divided by, or minus x.
Minus x, yes. Because you say that the whole point is 6, 3. I am assuming that this part itself is x. So what is left for this is 6, 3 minus x. Okay? And then it is just the transversal theorem, yes? Because it is simple. The point is that I do not have two unknowns. I have only one unknown. Of course, that unknown is both involved here and there. But that's not a problem because that's only one unknown. So what I write 6 over 3 is equal to 6, 3 minus x over x. This is an equation in which I have to find one unknown x, and that is enough. So I would prefer to simplify things. So this becomes 2 over 1. If I simplify by 3, is 6, 3 minus x over x. And then it means that this times that is equal to this times that, yes? And then I move this to the other side. It becomes 3x is equal to 6, 3. And then I want to find x. I divide by 3, so this becomes 2, 1 centimeters, yes? That's the answer. That's also very simple. Okay, there is another problem in the book. I don't know. This is not, I don't understand. It's not related to this, but it is expressed here. So let me also try to draw this and solve it together. So that is, of course, in my book it is 50, 36. I don't know if that's, of course, this number is probably not the same number that you have in digital copy. I will see that later, okay? But the point is this. You have a triangle. This is not related to this theorem directly, but this is related to this topic at least. So you have something like this. Let us see why they have mentioned it here. So you know that from this to here is 25. Okay, so everything is expressed in centimeters. Okay, and I ignore the significant figures. Okay, let me just write 25. And then here it is mentioned this is 24. And then you have this line somehow here. Okay, it's, of course I cannot draw precisely, so it might be a little bit misguiding you about what you're supposed to do. But this is mentioned that this angle and that angle are equal. They haven't talked in words, but they have put a dash here and a dash there. It means that they are telling you that these two angles are supposed to be equal. And then they have mentioned that this length is 12. And then you are supposed to find x, you are supposed to find y. Let us see if we can do this together. And if you don't mind, let me name them so that if you want to talk something, I can understand what you mean. Let me put this name A, B, C, and then let me call this point D. Okay. Based on the information provided on this figure, we are supposed to find the value for x, the value for y. And I told you it's not related to this because you don't have any top triangle. It's not, there's no parallel lines here. Yes, please.
I would use Pythagoras theorem to find CD.
No, because you don't know.
Oh,
we don't know there is a right angle triangle involved. Even if it is right angle triangle to your eyes, but you're not allowed to use it unless they have explicitly mentioned that in the problem. Any ideas? Yeah, I would consider this a good problem. I don't know why it appears here, because that is not related to top triangle theorem or something. But it is related to similarity. My picture is of course very, very poor, but hopefully don't rely on my skills in drawing. Rely on your own logic. So can you see two similar triangles involved in this case?
Yeah.
Which triangles are similar in this figure? Yes, Ali?
Or C, D, A, and A, D, E.
C, D, A. This is D. C, D, A, you mean?
Yes, and the C, B, A.
I don't see why this is true. I'm not saying that you might be able to defend yourself, but I don't see if that's true. Yes?
We don't
CDA and DBA.
CDA and DBA. No, actually, that is what Ali mentioned.
No, he said C.
we don't know that it is the right.
No, we don't know. Why do you think it's a right angle? Might be that my picture is very poor. So let me, of course, if I want to increase it a little bit, then I will just destroy the other part, because it is not easy to draw these things with hand. But anyway, this is the case. So which triangles are similar? No, but so you shouldn't get confused. There is a reason that they are telling you that this angle is equal to that angle. Why they are giving you this piece of information for something. So it means that the triangles involved. What are the triangles involved? Yes?
Shouldn't they all be like similar because they are a part of another triangle?
No, that was for right angle triangle.
Uh-huh.
Don't get confused about these things, yes?
But the angle B is same in ADB and BAC, so at least they are similar.
Yes. That's correct, because angle, let me call this one angle A1. So I am considering this triangle with the biggest one. They are similar. Why is that? Because they are telling you that angle A1 is equal to angle C. This is given directly. But there is no need to say that this angle is in common, yes? This angle is an angle for this triangle as well as the biggest triangle. So I would say that the angle B is the angle in common, yes? Based on the equality of these two angles, I can conclude by angle-angle theorem that which triangles are similar? The triangle ABD is similar to the bigger one, ABC, okay? But let us train ourselves now. I want to write something. So here, ABD has three sides. So AB, and then what is the other one? AD. What is the other one? DB or BD. Then I want you to write something, so I want you to fill up these gaps. If these two triangles are similar, so I should be able to write equality of three ratios, yes? I chose to put the smaller one, the sides of the smaller one in the numerators, but I am waiting for you to fill up the gaps here with the sides of the bigger triangle ABC. If I have chosen AB from the smaller triangle, can you tell me what should I choose from the bigger triangle? Yes, Elia? Yes?
CB.
Okay, so let me check myself. AB, you are saying that CB, the longer one, yes? AB and CB, yes, that's correct. So, or BC. Is that understandable or not? Okay, this is a little bit tricky. Let us go to AD. Can you tell me if I write AD from the smaller one? Don't get confused, by the way. Yes? What is AD? If I write AD, can you tell me what should I write?
It is ACC.
AC. Everyone agrees? Okay, this is a little bit better understandable. Why? Because when you say AD, this is AD. In this smaller triangle, AD is opposite to B. But in the bigger triangle, B is the same as B. The opposite side to that is AC. So that's one way to understand that. Of course, if you have a good imagination, you can rotate or, I don't know, reflect it somehow that you can write these things properly. Of course, when I write BD, what will be the next? What? That's the only one left. AB. So I would consider this, I don't know, if you can understand how to write it down, it means that you are really on the safe side. You are really understand what is similarity, but might be somehow you get confused. Everyone agrees that what I have written here is based on the similarity of those two triangles, yes? I mean, this is a good example because it, first of all, it is simple, not that complicated, but not too simple. So it means that you have to have a good imagination to be able to write these things down. So is that understandable or not? Sergey, are you happy? Or confused?
No, I came up with the right answer, and now I can't remember how I came up with the right answer, so I'm just trying to figure it out again.
So what I'm thinking that, okay, because this angle B is the same, so I would flip this so that this side matches with the longer side, yes? So AB matches with BC, that's correct. So I don't know, you need to imagine that I bring this triangle and let's revert it in a way that this side will become similar to that one. So what I'm saying is that I can keep this bigger triangle like this. Yes? And I bring this out, and then let us just draw it another time. So I would say that because this angle is B, I cannot change the angle, so I have to keep this vertex the same, but I can flip these two, okay? So what I do, I will say that I will have this scenario, yes. So I will flip this one, then it will go up. So AB, it's hard to draw, yes, because AB, so this becomes B now, but then AB goes here, yes, and then the other one is what? D, so D goes somewhere down, yes, so this becomes something like this. So you see I am keeping the B the same. Now, so this is the way that you have to imagine that, yes? Because this A will match with this one, so this means that this angle will be the same as this angle. But I don't know how you can imagine it. This is one way, of course. Yes? Anyway, let us try to see what we have and what we need. So if instead of AB, can I write something? Yes. Instead of AB, I can write X. Instead of BC, it is directly given to me, 25 is equal to. Instead of AD, I can write 12. Instead of AC, I can write 24. And instead of BD, what can I write, by the way, for BD? It's Y. And for AB, I can write X again. Am I right? Yes. Yeah. Okay, but that is very simple now. Because you take these two and you answer X. When you found X, you can use these two and the X you find Y. It's simple, yes? So what you do, so let us take these two. X over 25. By the way, it's very simple. It's 1 over 2. Yes? So it's 1 over 2. So this means that 2x is 25. This means that x is 12.5, yes? Centimeters. And then when I know x, I take these two this time. Let me write here up there. It's already 1 over 2 again. Y is not known, but x I just found it. It's 12.5, yes? So then it means that 2y is equal to 12, 5. So that means that y is half of this one, which is 6, 25 centimeters, yes. But of course, if you want to keep the significant figures, so we have only one significant figure, so we have to get rid of that. Two significant figures, we have to get rid of 5. But that's okay. Any questions? Okay, so that was a good problem. It was simple, but not too simple. So if you really understand what you have written here, it means that you really understand what is the similarity and you don't have any problems. Might be, of course, the problem is complicated. We have different triangles to consider. Even that's hard for me as well. But that's a different issue. It doesn't mean that we don't understand this. Okay, I see also another problem in the book. It seems nice. Let us work on this one as well together. What I see is this picture. They have written that in a right angle triangle, in a triangle ABC, a square is inscribed. So this is more or less they have drawn the picture so that you're not confused. So we have a triangle here, and then you will see why this is definitely a right angle triangle, because they have mentioned that there is a square inscribed. Okay? Something like that. It's really bad, so I have to use the ruler probably. Okay, but that's okay. So you have this triangle A, B, and C, and you know that this is a square. And they have mentioned that this is a little bit, okay, so from here to here is 7, so let me write, AC is 7, everything in centimeters, and then they have mentioned that AC, no sorry, AC is not 7, AC is 3, and then AB is 7, and then you are supposed to find the area of the square. You are supposed to find the area of the square. So you see that this is a square, so automatically it means that this angle is 90. And then they have given you those two numbers, you are supposed to find the area of this square. So how do you think we can solve this problem? Yes?
So the top
Louder, please.
the top triangle and the triangle, the other triangle inside.
This one and that one.
Yeah, they're
Okay.
similar
They are similar. Do you have any argument for that?
because they're.
So let me name them so that if you want to name them, so let me call it M, N, and P. Okay. So you are claiming that this triangle MBN and this triangle PNC are similar.
Yeah.
Okay. Why?
Because they are in a right angle triangle.
So one of them is of course 90, but what is the reason for the other one? So this is 90, I agree. That's also 90 because that's a square.
Yeah.
Okay, but that's not enough. I need one more angle at least. It's because one angle is equal to one angle, but you need another angle to be equal to another angle.
Angle N and angle B.
This one and that one.
No, the other side.
This one and that one.
No. Angle N, like,
This one.
yeah,
Okay.
and B.
They are also equal. Why?
Because.
Yes, you are right. They are equal, but why?
I just did it. I don't.
No, because these two are parallel. Yes. And this is transversal. But this means that these two angles are corresponding. They are equal. Yes, you are right. So this triangle is similar to that triangle if you insist to do that. Okay, but then do you think it will help us? Because if I want to find the area of the square, I have to know the side of the square and then multiply it by itself. So the point is that I need to find this x, or I don't know, this x, or this x, or that x. All of them are x, of course. I need to find somehow x to be able to find the area of the square. Then how can I use this piece of information that you provided for us, the similarity of these two triangles, to be able to find this value of x? If you want, I can write the numbers here on the board. From here to here is 7. From here to here is 3. Oh, again, I made a mistake, I think. Okay, so sorry. So this one is called B, this one is called C. It doesn't matter anyway. What I have written is correct. Okay, so this is my situation. I want to find that x. That can happen. Can you here continue yourself? So you got that is correct, but what should I do then? Yes, Malika?
I don't know, we also know that ABC is similar to both of the other ones.
A, B, C, what? Also that's similar to other ones. Yes, that's correct.
I guess we could do, like, I don't know if this works, but like, thinking something like AP divided by 7.
Yes?
And then AM divided by 3.
AM divided by?
3.
Somehow it works, I think. It's not wrong, but you need to use the theorems, yes? You cannot just randomly write the ratio. So you need to tell me what is you are using, you know?
Right.
Because, so I would say that, okay, first of all, do you agree that this line is parallel to this line?
Yeah.
Okay? So if you don't look here, this is the top angle, this is top triangle, and that is the triangle. So this means that this one is similar to the bigger one, as you mentioned, yes? So we don't need to prove that again, because this line is parallel to that one. This triangle that you see here is similar to this triangle there. Then what I can write CM over the whole expression CA is equal to MN over AB. I want you to understand this is correct. So you see, I told you that if you draw something like this, you can write this over that is equal to this over that, but you are not allowed to use this anymore. Or you can do this. You can say this one to the whole one is equal to this one to the whole one. Then in that case, you can also get involved with these two. That's also true. So this is the second one that I am using. So I am telling you that CM over the whole CA is equal to, of course it is also equal to CN over this whole CB, but that's useless. I don't have anything regarding them, so I don't bother to write it down even. But I would say that this is MN over AB. Yes? Is that understandable? So there is a third one that I ignored because it is useless. Okay, so what is CM? CM is this small one. But from here to here I called it X myself. The whole thing is 3. So what is left for CM is 3 minus X. Over CA, over 3, is equal to MN, which is X, over AB. AB is from here to here is 7. So this is an equation that I am supposed to solve. So then it means that I multiply this 3x is equal to 7 times that 21 minus 7 times x. I move this to the other side, it becomes 10x is equal to 21. So this means that x is 2, 1 centimeters, yes? And then the area of the square becomes what? becomes 2 comma 1 to power 2, which is 4.41 square centimeters, yes? So be careful, you have to use these theorems in a correct way. So you have to decide, is the top angle theorem useful or the transversal theorem is useful? Whenever you want to talk about something about these two that are parallel, you have to use the top angle theorem to use similarity. But of course, if you want to only consider these parts, then you can use also transversal theorem. Yes, is that understandable? Okay, so it's enough for today. I will stop here, but you will not learn geometry if you really don't solve the problem. So I really recommend you solve as many problems as you can. I will update the Google Classroom right away so that you know what to do, okay? Thank you.